Hello and welcome in this new video. Today we're going to solve this case, which is an old one called Square of Fortune, designed by Joseph Palisok, who is another regular competitor of the FNWC, and also actually a colleague of mine. So Joseph, if you're watching this video, hello. Let's see what we have. So I think this game is very common in many countries. For example, in Italy we had a very similar one. Basically, is a turn-based game. The player, I think, will spin the arrow. Here we have the square that highlights the number of points available according to the spin you make. And then you will probably need to guess, okay, the sentence or the word or whatever. Let's see what the specifics are. So spin the arrow whichever send the arrow points to, that's how many points, 50 to 150, the player gets if they guess the letter correctly. The spins have a random strength of 1 to 24, and the arrow moves one cell at a time in a clockwise direction. Okay. Further spins in the game continue from wherever they finished the previous move. That seems logic. Okay, guess a letter. If player guesses correctly, they score points. A list of player answers is provided for each of the games. In the sequence, as the players name the letters columns A, I to B, H. Please note that the players are not too smart and will just call letters randomly. On the other hand, the players are quite careful and will not call letter that was already called previously. Therefore, the maximum number of moves is 26. End of turn, regardless if the player guesses correctly or not, then their turn ends and the other player's turn begins, except for level 5. Player who solves the word guessing the last missing letter wins the round. Okay, so let's see how this is structured. Assuming a player starts from the point shown above, given the following spin strengths, what point value will the arrow point to? Okay, so this is basically a simple first spin of the square of fortune. These words do not have repeating letters on which turn will the puzzle be solved. Okay, there are some words on level 2. These are the same words on level 2. What is the score of the player who will solve the puzzle? Okay, so this is basically a one player full game. The words can have repeating letters. Players score 2x, 3x points if the letter appears multiple times in the mystery word. What is the score of the player who will solve the puzzle? Actually, I will zoom in a little bit. Uh, Additional rules introduced. If a player gets okay, we'll see this later. Okay, so let's start from the basics. Assuming a player starts from the point shown above, given the following spin strengths, what point value will be the arrow point to? So we have basically a list of points that it's probably a good idea to replicate here. Let's use a little bit of formulas and manual approach. So we have this, and basically we are okay with the uh, half, first half of the square. Then we have this, which we could reverse by saying that I'm interested in the first and then in this sequence of 1, 2, 3, 4, 5, 6, starting from 6 minus 1. 81, 56, okay, so this is reversed and then I need to transpose this. So it basically went in this direction, so right to left for this piece of square. And then I'm missing this other bit, which is basically uh, again a repeated array, sorry, an inverted array with the wrong number, this time being the sequence of 1, 2, 3, 4, 5, 6, starting from 6 minus 1, and column number is actually not needed. And I also need to transpose this. So 70, 130, okay. And then we will have the last bit, which is luckily in the right direction. So those are 25 possible positions. Is this even correct? So 90, then I have 70 to 90, then I have 80 to 120, then I have 70 to 50, then I have actually it took 3 times this, so it's not correct. So it should be like this. Let's try 124. Okay. So it's basically 24. Okay, and they're basically saying if I start from the beginning, I apply a strength of 5, I will have 1, 2, 3, 4, 5, so 140. Okay, if I apply 24, strength will be 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we'll be back in the first position. Yes. So let's call these points. And let's say that I will have index of points on first, and I will need to have this +1. Yeah. Uh, but actually, if I apply a strength on 24, I will have issues because I will need to be back on the first iteration. And so this will be a mod of this 24 basically +1. So it is, if it is 24, I will be again in position number 1. But I think this is not enough because I will need to manage the uh, spin that will bring me over the 24, the place number 24. For example, if I spin with a strength of 10 and then with a strength of 20, I will have 30, which is of course not correct. So what I will need to do is whenever this be goes beyond 24, uh, I will need to go. I'm not sure actually this is correct, but let's try. Let's build this incrementally. The total will be 1870, and is actually correct. But with the second, sorry, with level 3, I will need to adjust the formula for this. In this case, the words do not have repeating letters. On which turn will the puzzle be solved? It's, I think, basically the max of match uh, of uh, mid of this sequence length of this one, yeah, exact match. So basically what I told to the formula, yes, is let's match every letter of this word against this array. The match returns the position of the letter in the lookup array, and I took advantage of the modern dynamic array formula by basically splitting the string into single digits with the mid function, so extracting basically the single letters using the sequence with the length of this word, and then basically taking the max of this resulting match lookup. Hopefully this is correct. So 391. Let's see. And it is correct. Okay. Okay, let's move on to level 3 because now we have to take care of the basically next iteration of the spin when I go beyond the position 24. So the same words on level 2. What is the score of the player who will solve the puzzle? Uh, these words don't have repeating letters. Okay, but is this actually with two players? This is the score of the player who will solve the puzzle. And so basically, I will also have to manage the turns for the game. Okay, whichever the player gets spins around on strength, so location of sense for the spin strength. Okay, I'm assuming the when player two spins, it will start from the position that player one left. So let's begin to build the approach for this. So I'm going to XLOOKUP this in column B, and I will look up over cells basically H to BH. Okay, it is called sample 3 actually. Okay, and I will transpose this, and I will transpose this, which actually are the spin strengths and the letter to be guessed. And I also will need to look up actually the word itself. So I will need another small lookup here. Actually looking up column E. Okay, so the letter will be the word will be the word or in this case. What I want to do is let's call a start position, which will be 1, uh, and position points guessed. So this end position will be very much similar to this one, with the exception that this will be my nope, because this is already the points actually. So it will be this plus this, the end position. Um, what if I apply here the mod of 24? Yes. So we'll have this and this. Okay, and I will need to say if this greater than 24 actually will be, no, I'm sorry. Why am I pointing J12? Okay. Uh, let's say let x equal this, then if x greater than 24, we will have x minus 24 plus 1 probably, otherwise x. Okay, let's see if this works. So what we have is I'm in position 22. I'm spinning another 18. I'm in position 22. I'm spinning 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It gives me position 16. So probably I don't need this plus 1. Okay. And then this will be basically the index of just this. So end position 22 is actually 50 points, so that's correct. 16 is 120, so that's correct. Okay. Uh, okay. In terms of guessing the letter, we have if um, not is error, find this here, one otherwise 0. Okay, let's see. Okay, and we have the ones the corresponding position. I will drag down also this, then I will manage the turns. So we start with player 1, and then it's basically if this equals 1, 2, otherwise 1. Okay. So what is the score of the player who will solve the puzzle? The player who solves the puzzle is guessing the last missing letter wins the round. So actually, the winner uh, probably overcomplicated this a bit, but will be the take filter of this when this equals 1 minus 1. Yes, so basically I'm saying first of all filter this column when the guess has been made. So basically we'll output a 2 rows list and then take the last one. So in this case we'll output 2. And P P1 points, P2 points will be the sum ifs of those lock where this equals 1 and this equals 1. We'll have to lock everything. And this will be the 2. So 250 seems correct. So the output will be if this equals 1, this one, otherwise this. Okay, let's try to build a data table to scale for the whole data set. Okay, it asks for data 41 to 60. Okay, let's see. 4980. 4,980. So 290, 370, 180. Okay, it's correct. Level 4. The words can have repeating letters. Players score 2x, 3x the points if the letter appears multiple times in the mystery word. What is the score of the player who will solve the puzzle? Okay. So This time will be sample 4. Uh, check mult points 2. So uh, so this checks if it's actually not updating. This checks if we are able to find this letter here. I'm now interested in seeing how many of those I have. So this will be the len of this lock minus the len of substitute of this lock. Old text will be this one, new text will be nothing. Uh, so basically we have one E and two T's. So this is correct. And the points will be basically points times guessed times the multiplier. And I can take basically advantage of this, move here this one, and I will probably also need to remove this, but it will work anyway. So that will be player 2 in this case. 170 and 60. Nope. So why this is okay? I will. Something weird is going on here. Why am I taking up to this position? Does it have a different structure? Actually, no. That's very weird. Also because how it is possible that the previous one was okay. And this says 120. Okay. I honestly have no idea how this could have shift, but anyway, so we will have data 61 to 80, uh, which is this, which is this, 10,230. Yeah, so for 31, 40, 150, 31, 40, 150. Okay. Last one, very hard. Additional rules introduced. If players guesses a letter correctly, they get another turn, spin again, and code the next letter according to the sequence of moves. The player who solves the puzzle gets double their total points, and the player who didn't solve the puzzle still gets to keep their points. The winner of the round is the player with the most points. What is the score of the player who wins the round? Okay, so basically the logic for the turn is no longer this one, but I will have to say if this equals 1, then this, otherwise if this equals 1, then 2, otherwise 1, which I think is what we need. Let's see. So 1 then ends over to 2, then 1 and 2, then 1 and 2, then 1 and 2, then 2 actually guesses the letter. Nope. Actually, I need to check the previous row. So, okay, it will be like this. So, one guesses and then plays again. Here, two guesses and plays again. Okay, I think the logic to understand who is the winner will stay the same. What is actually happening is that the player who solves the puzzle gets double their total points. So the player solving the puzzle will be actually this one. And so it will be if this equals 1, it will be this times 2, otherwise this, because they keep the point. And then time if it equals 2 equals. And then what is the score of the player who wins the round? So not the score of the player with the most points. And so actually is the same thing, just shifting the results here. I put a comma, which is not needed at all. 600, and I need to change the sample. Wow, it is incredibly slow. 600, 600. Okay, and I will need data 81 to 100. 18, 80, 40, 19, 20. So it's actually not checking out. Let's see, where do we have a problem? We're 26-ish minutes in, so actually this is very bad. Oh, I think I've already figured out why. So, 2, 6, 4, 20, 26. Okay, we have a problem here actually, which I was not expecting. And then we have actually we don't have a problem for this one, which includes spaces. We have a problem for this run between word, which is dataset 88. Let's see why actually. Mm, that's interesting because the answer should be 66, which is actually the score of player one. But it's actually player one to win the, sorry, player two to win the round. So the A gets guessed by player one. So player one plays again. Guess is also the N, which is double the points. Then two, then one again. One, 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 one. Always player one is guessing, and then by chance player two ends up guessing the last letter, which is actually this one. So I'm honestly not getting why this should be wrong. If player guesses a letter correctly, get another time, spin again. To see what's for most, the player who solves the puzzle gets double their total points, and the player who didn't solve the puzzle still gets to keep their points. The win of the round is the player. Ah, okay. The win of the round is the player with the most points. So it's actually just the max of this. I misread the instructions. And let's see. 19020 and 19020. Okay, checks out. Okay, spot on the 30 minutes, I think. Thanks a lot for watching this video, and we'll see you in the next one. Bye.